Let us ace our exam like a pro. Here are top derivative questions from the past test papers. Unit 2. We are going to take questions based on the derivative rules, which include the sum rule, the product rule, quotient rule, and the chain rule. 10 questions from the past test papers will help you to prepare for the test and ace it. That's the whole idea. Perfect. In this playlist, you'll find solutions for all the 10 questions. In case you need the PDF, send an email to globalmathinstitute@gmail.com. Follow our playlist to master the strategies and learn more. I'm Anil Kumar sharing with you the solutions of these questions one by one. So let's begin with the very first question now. So normally, when you begin with this test paper, what you notice is the first question is straightforward, knowledge and understanding base, where you have to find the derivatives. Questions are much simpler than what you see here. Well, these are selected few difficult questions from past 10 years of test papers, right? So that's the beauty. So, the very first one is write derivative of following functions with respect to x, right? So that's what it is. F of x equals to square root of x plus square root of x square plus 1. G of x is 3x square minus 1 to the power of pi times 2x plus 3, and h of x equals to square root of x plus 3 over x square minus 1 whole square. Now I've seen from the past test papers where students make mistake and how we can overcome these mistakes. So that is why I am selecting these questions. The very first one is a shocker for many students. They don't really get it. How do we apply the chain rule to get the answer? In the second, we have pi in the exponent, which is a very difficult number to work with, especially at this stage when you begin with calculus. And then we have a radical function, which is 5 to the power of 2. Some students struggle working with uh, these exponents, which are rational in nature. Correct. And that's the reason why these three questions have been taken. Accordingly, my set of 10 actually includes very beautiful questions which will help you understand the topic better, and thereby you will be able to ace your exam like a pro. I hope it makes sense. Perfect. So let's begin with the solution of the very first question, which is right here. We are given f of x equals to square root of x plus square root of x square plus 1. Couple of ways to do it. You could say inside function is u and then apply the chain rule. However, I hope at this stage you know all those things, so we'll go kind of straight. So we are saying the derivative of this particular function, which we need to find with respect to x, is derivative of all this. So as you know, derivative of square root is 1 over 2 square root x, right? So I'll write it straight, which is 1 over 2 square root of x plus square root of x square plus 1. Make sense? Correct. So that's the derivative of the function. Now, we have to times this with the derivative of inside function. The inside function for us is x plus square root of x square plus 1. Make sense? That is the inside function, right? So these are the critical steps involved. So I've skipped one or two right there in the beginning, right? Since I hope you know all that. Correct. So it is 1 over, so I'll repeat this, right? 2 square root of x plus square root of x square plus 1. And what is the derivative of this function? Derivative of this is x derivative is 1. And again, we have square root, right? So square root will be in the denominator. We'll write 2 times square root of whatever it is. x squared plus 1. And we have to multiply it once again with the derivative of inside function. Now, inside function here is x squared plus 1. What is the derivative of this? Well, the derivative of this is 2x. So I'm writing it straight here, right? So saving some space just because I will just put it right there in one sheet. Clear, right? So that's what we did, correct? Now, to just explain to some of our viewers, let us say we have a function y equals to square root of u, right? So some of the students will write this u as to the power of half. And then we'll say, well, y prime, or let's say dy du, right, in this case, will be half of u to the power of minus half, right? And after this, they will write 1 over 2 square root of u. You get this whole idea. So all these steps which you see here uh, are done by the students. No harm doing them, but you see the result, right? So normally when you have a square root function, it is 1 over 2 square root of that, right? As you can see here as a result. Now, the concepts are not very clear to some, and that is why we use this particular method to explain it in more details, right? Explaining more details does not mean that include redundancy in your solutions. Time is precious, and therefore, I will suggest follow this method, which is absolutely correct. Do not split these radicals as to the power of half, to the power of minus half, and things like this. Okay, great. So you see, we have here also done a straight thing. We included two steps here. This explanation is important since I've seen students wasting a lot of time in solving test papers, thereby not completing it and missing a question, the last question especially, means you're taking a hit of at least 5%, which is not good enough. So we get to the result simplifying, cancelling out these two 2's gives you the final result, right? So which is 1 over 2 square root of x plus square root of x square plus 1 times 1 plus x over square root of x square plus 1. Make sense? So that is the solution of question 1a. If you have any doubts, feel free to write your comments and we are there to support you. And look in the playlist for many other questions. Now, let's look into part B of this question, which is where you get pi in the exponent, right? So, pi is just a number, right? Okay, it's a real number. So, we have g of x equals to 3x squared minus 1 over to the power of pi times 2x plus 3. Product rule will be applied, as you can see, along with the chain rule. So power rule, chain rule, product rule all combined together. So the derivative will be derivative of the first function, which is pi times 3x squared minus 1 to the power of pi minus 1. That's a critical step. Times derivative of inside function. Let me write here very clearly. Inside function is 3x squared minus 1, correct? Times the function which is 2x plus 3, correct? And now we'll add to this the first function times derivative of the second, right? So which is 3x squared minus 1 to the power of pi times derivative of the second straightforward. So 2x plus 3 derivative is 2. So I'm just multiplying it by 2. Makes sense, correct? Okay, great. So we got this. Now let's rewrite the derivative. So we have pi times 3x squared minus 1 to the power of pi minus 1, critical step, times derivative of 3x squared minus 1 is 6x, times 2x plus 1, 2x plus 3, the second function, plus derivative of the second. It's a good practice to write the numbers before. Okay, so we got 2 times 3x squared minus 1 to the power of, you get the whole idea. So that's what we get. Now, at least you can factor out few terms, right? So 2 times 3x squared can be factored out. So I'm changing the ink and writing this step, which is 2, and we have 3x squared minus 1 to the power of pi minus 1. You get the whole idea. We'll factor this out. So, so since we factored this out on the first term, we have 6 divided by 2 is 3. So we have 3 pi x, right? So we have 3 pi x times 2x plus 3, right? And on this side, we have plus 1. Since we factored out 1 times pi minus 1 was factored out. So we have 3x squared minus 1. 2 is also factored out. You get the whole idea, right? So that is what we get as our answer in the factored form. Most of the time, we do not mention here that simplify fully. If it is mentioned, you may have to go 1 or 2 steps more to write it in more simplified form. However, this is good enough to give you full marks when the question is as it is written here. You get the whole idea, right? So I hope you've understood. You've also understood that it was kind of important to factor, right? That also gives you communication marks, and you don't lose zero point 0.5 if your teacher is slightly strict. Okay, great. So let's now move on to the third question, which is kind of straightforward, but has the radicals involved. And what I've observed is that whenever in any questions the powers are rational in nature, students really some make some mistakes, right? So let me rewrite the question as some of you will like to. So we have square root of something to the power of 5. So that really means that something x plus 3, which is in this case, over x square minus 1 is to the power of 5 by 2. So that is first thing which you need to understand very clearly. So, and it's being written here so that you do not make a basic mistake. Correct? So now we can apply the power rule first and then the chain rule to get the derivative. Correct? So we can write down the derivative. So let me write down the function first in this particular form, which is x plus 3 over x square minus 1 to the power of 5 by 2. Correct. So now we have the function. We'll first apply the power rule, and so the derivative will be what? So derivative of this function will be 5 by 2 times x plus 3 over x square minus 1 to the power of 5 by 2 minus 1, right? So 5 by 2 minus 1 means 2 is a common denominator. Minus 1 means 2 over 2, right? So we get 3 over 2, correct? Is that clear to you? 5 by 2 minus 1, right? So it is 3 over 2. So we subtracted 1 from 5 by 2. Now we have to multiply with the derivative of inside function. You get the whole idea, right? So we have to now multiply with the derivative of the inside function. So what is the inside function? Inside function is x plus 3 over x square minus 1. We can apply the quotient rule, correct? So if you apply the quotient rule, then you get the denominator square, which is x square minus 1 whole square. Derivative of the numerator, which in this case is 1. So we get x square minus 1 here minus the function x plus 3 times the second function derivative, which is 2x. So I hope this step is absolutely clear, right? So that is where you get. So now you see we have 5 by 2x plus 3 to the by x square minus 1 to the power of 3 by 2 times x square minus 1 minus x plus 3 times 2x over x square minus 1 whole square. Now, if you have to simplify this, you see in the denominator we have x square minus 1 to the power of 3 by 2 and square. So they get added up, right? Correct. So when you add 3 by 2 plus 2, correct, which means what? So, which means you get 2 plus 3 by 2 plus 2, because 2 you have to make a common denominator. You get 7 by 2, right? So let me do that step here, and then I'll leave you that, please. You can further simplify. You get the whole idea, right? So we have 5 by 2 here, And in the numerator, I'm writing x plus 3 to the power of 3 by 2. Correct. And here in the numerator, we'll open this up, x square minus 1 minus. So open this up, which is minus 2x square minus 6x. Correct? Over. We have x square minus 1. So we are doing 2 plus 3 by 2. Let me do it here. 2 plus 3 by 2, right? So it becomes what? 2 times 2 is 4, right? So 4 plus 3 by 2. 7 by 2, correct? So this is especially for those students who are struggling with working with radicals, right? So that is how you're going to simplify it. So I hope it makes sense. The other simplifications are very simple. You can actually figure out what is there in the numerator, that square bracket, simplify, write down your answer. Makes sense, correct? So with that, we have solved the very first question of this particular test. I hope it makes sense, correct? So we have understood strategies of how do we really apply the rules, which are mainly sum rule, product rule, quotient rule, and the chain rule to find the derivatives. Also, we have learned the techniques of simplifying. Many times, these questions, a comment is written there, simplify fully. In that case, the last example could have been slightly more challenging. So, I like you to practice that. I hope it makes sense. Perfect. All the best for your exam, but follow our playlist to really do better. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thank you and all the best.